Okay, East Jackson. It is a Thursday, September 20th. We're here going over our study guide for the Unit 2 test. We're on the back of the first page. We're looking at this particular problem, and we have established that the unit rate, or the rate of change, is -6 because it's going out or leaking at 6 gallons per what? Hour. Good. Excellent. Now, so we've already said what it represents in context, right? Context means, hey, in the word problem, what does that slope mean? It means that joker's leaking 6 gallons per what, guys? Per hour. Good. Now, we call that a slow leak, right? We established that yesterday. It's a slow leak. It'd be there, 30 gallons. It would be there. We'd be able to swim in it, come out next morning, and it'd be what? Gone. But we swim in it all day, and we're fine, right? Yeah, good. Now, ladies and gentlemen, what is the y-intercept? Yes, ma'am. 30. Why do you say 30? Okay. That is what you started with. So how does what you start with and the y-intercept, how do they coincide? How do they correlate? Why did you pick 30? What is the y-intercept? It starts on the y-axis. That's correct. What does it represent? Now, it's a point on the y-axis, but what does it represent within the x values? Think about the ordered pair if you have a point on the y-axis, gentlemen and ladies. No? Anytime, listen to me, this is very important, guys. Look at me. Hey, right here. Look at this ugly mug. It's not half as bad as the ones I'm looking at. Now, love you. Pay attention, right here. Now, it's what you have in the very beginning, before anything ever happens. That's what the y-intercept is, right? Because your x value is 0. And your x value is something normally that's happening. And for this, x is just time, right? It's in hours. Before you even begin, we have 30 gallons in that little swimming pool, right? That's right. That's what it means. The y-intercept in a contextual standpoint means I have 30 gallons in there before we even do anything, right? Before it even starts to drain. Okay? Y'all with me? Okay, so we're good on that? So do you understand what it means by the y-intercept representing in the context? What does it represent in the context? What does the y-intercept represent in the context? How much they started with before what? Started leaking, right? In the beginning, we had 30 gallons, right? In the beginning. Time equals what? 0, right? Okay, so you got to make sure you understand that. Now, 2, I need you to write an equation. Hopefully you did this last night. If you didn't, then shame on you. If you did, we'll check it. But let's give you about 15, maybe 20 seconds to kind of relook at your equation, and let's see if you still agree with it or if you want to tweak it. Fair enough? Go. Okay. What is the equation? Go, Sarah. Y equals what, babe? Negative x plus 30. I agree 95% with that. Negative 6x. There you go. Negative 6x, right? Y'all agree? Now, negative 30x plus 6. Okay, you swapped your slope and your what? Y-intercept on that, right? So let's take a look at how we can keep that from happening again. The y-intercept's the b, right? The slope is the who? You remember on the problem we said, where is it? Where do you see the slope in the equation? Where do you see the y-intercept in the equation? The slope's in front of the x. The y-intercept's in the back of the x, right? Comes after the x. Y'all remember that? Yeah? Yeah, let's don't pop a gum. You can pop friends, but not gum. Okay? Good. Now, y'all ready? How did you do? Just curious. How did you do? Be honest with me. Okay, so what did yours look like? No. You can't have y equals negative x and say you got the same thing. You just did put negative plus 30. Okay, but negative x plus 30 is not the same as negative 6x. Does that make sense? So you have more than one thing. You have two things wrong on that. Yeah? Any questions before we move off this? Anybody? Okay, folks, next, turn your page. Go to the second sheet. You have graphs, do you not? There you go. We are defining slope. So hopefully you found slope last night, right? Hopefully. Yes. If you didn't, then you're missing out on an opportunity. I'm going to give you 15 seconds. No, I'll give you 30 seconds. That's 15 seconds apiece to find slope on these two, ladies and gentlemen. Okay? You need to step up the game. Let's go. Anybody want to give me a clue or a hint on how you find slope on a graph? Anybody? It's one word. You say this word and it's like ding, 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 winner, winner, chicken dinner. What is it? Nope. Ready? 1, 2, 3, go. What? Triangle. What does the triangle help you get? Change in what? Y's, and you're changing what? Thank you, ladies and gentlemen. Look right here. This is going uphill, so my first dot will be at the y-axis, right? Wherever it crossed the y-axis. That's normally going to cross at a perfect grid. So you can always go to that one, right? This one just happened to cross at the origin, and no big deal. It's still a point on the y-axis, right? I am going up this thing right here until I find a perfect grid, and it's right there. So all that I'm doing is up and over. So 1, 2, what? And then what? Now, from this point, there's something that I've done that if I don't do, will cause some of you to make a mistake.
I don't know how to find the perfect grid. I don't know where to put the two dots.
Okay. Okay. I realized that your graph, will y'all grab the door, please? I realized y'all's graph didn't copy as good as it could have. Ooh, excuse me. As good as you could have. Okay? But, based off of what you could look and discern from it, you should have came up with 3 and 2. But this is a change in y, and this is a change in what? So what is slope? 3 over what? Now, is it positive or negative? Why is it positive? It's a positive slope. How do you tell somebody? If you say it's a positive slope and don't know how to do it, they're walking where? From left to right, they're walking which way? Up. That's exactly right. You're exactly correct. So you got to know what it means to have a positive slope, and that is to look at it from left to right and walk. It's going uphill. It's a positive slope. Now, let's look at this other one. Yes. You good? Huh? I know it didn't do as good. All right, but where's my first dot going to be? Right there. Right there. Y'all see it right there? Right there. All right. Over there. All right, y'all ready? Here we go. Right on the x-axis, right? Correct? Anybody concerned? Any questions on that? You with me? Yeah? Give me a thumbs indicator. You know what I'm talking about? You know thumbs? Like, this is jam up jelly tight. This is like, I'm a little shaky. Shake and bake, baby. And this is, oh no, we in trouble. Right turn. Little shake and bake there. Who's shaking and baking? Huh? All right, what's the biggest question you got in your shake and bake?
Where's the bacon?
We can't talk about that. Now, Talladega Nights. That's all I say. Shh. I need to know what your questions are, and you're shaking and baking. Your thumb sideways, right? Son, put it in the microwave. Hit the thing. You'll be okay. 10 seconds, you take it out, and you'll be some soft, soggy bacon. In 15 seconds, it's crispy. Now, son, stay on the track. We're going around. All right. Where do I go now? Hey, where am I going? My objective is to find me another perfect what? Grid. So yours is probably not the best, but right here it is. So I'll go down and over. Note that when I draw my triangle on a negative slope, that it's underneath, right? So how much did I go down? 2. How much did I go over?
1.
Thank you. What is my slope?
2.
Negative 2 over 1. Do not write 1 over 2, ladies and gentlemen. If you'll write changing y over changing x on these things, when you put them in, you will not make a mistake. Your eyes will see it. Things will happen. It's called learning. And it's called recall of understanding. Now, why did I put a negative? It's going down from where? Left to what? Good. Now, any other questions on these graphs? Do you have plenty of examples to go back and look at? Oh, yes, you do.
I didn't get that same second point. I got the first point that you put down, but I didn't get the same second one. I went down a little bit more.
Yeah.
But I still got the same.
That's exactly correct.
I got 6.3.
Which reduces to who? That's the really cool thing. You don't have to hit the first perfect grid crossing. You just have to find a perfect grid crossing and just count. That's exactly right. It doesn't matter where. It just has to hit a perfect what? Grid. And you count how much you're moving in your Y's. You could have had 8 and 4. That still gives you what? 2, and it being a negative slope would have made it negative 2, right? Y'all with me? Yes? Okay? That's the really cool thing about slope. That's the kind of realizations we need to be having. But you need to be having those based off of, guess what? Thinking, right? Y'all with me? Yeah? All right, so the next problems are ordered pairs. How'd you do in your ordered pairs? Here's my 9 and 10. Please check it against yours. Note that we settled on this way the other day. Right? 9 and 10 is there. Huh? I need you to check yours against mine. We need to see where we're different and where we're the same. Good, good. You got some success on number 10. I need you to look at this. You can't get 10, negative 10. Y'all remember? Let's kind of recap. Stop, drop, look, and listen. Stack your coordinates, right? And go top one minus what? Bottom one. Top one minus what? That's right. For the x's and the... Is it not the equation up there? Yes, it is. But it takes the opportunity or the odds of you switching x's and y's away because they're stacked, right? You just got to know that, hey, guys, I have to subtract them, right? Right? And then when I subtract them both, all I do is take the x and put it underneath the what? You see that line? It's moving over, making a fraction, right? Yes. What now? Okay, now, listen to me. He brings up a really good point. He said 4 over 3 for number 10 simplifies down to 1 1/3. Look at me. Stop, drop, look, and listen. We will never, ever, ever will we talk about mixed numbers again. When you have an improper fractions, ladies and gentlemen, you're in big boy world now. You leave them as improper. You do not change them back to mixed numbers. Do you understand? Okay? We don't have to do that no more. Life is over with that. The only time that you would is if you're talking about a measurement. If you're talking about a measurement. And the measurement, would it make sense? Okay, so we clear on that? If it is an improper fraction, ladies and gentlemen, we will leave it as an improper what? That's exactly right. Yeah? Now, any questions about what we've done here? I'm going to give you a little bit of hints. If you don't pick up a calculator and check your thinking, then you can't become confident in your thoughts and your abilities. Do you understand me? Your calculator will help double check your signs and the reduction or simplification of your fraction, right? Yeah? Yes, sir. How did I get a positive 4 over 3? Well, 5 minus 2 is what? 3. And 4 minus 0 is what? So both of those numbers are positive. Now, I'm not looking at it in terms of change, right? If I were to look at it in terms of change, both of those would be negative, right? And a negative divided by a negative is a what? That's exactly right. Okay? Yeah. Okay? When you're doing it by the equation, you're not, it's a different mindset. It's a different way to do it compared to looking at if it's going up or down the number line, right? It's strictly this one minus this one. Yes. Yes. Now, I need you, I'm going to stop it for 1 minute. I need you to do 10 and 11 or 11 and 12. I need you to double check it. All right? Go. All right, ladies and gentlemen, we're checking 11 and 12. Ready? Go. How'd we do? Woo, raise your hand if you got success. Man, look at those hands. Got one right. Find out what you did on the second one then. Y'all good? Some of y'all are copying. If you're copying, guys, that results in a bad thing. Come here, I can't hear you. You put number 11 what?
Around.
What do you mean around?
I put the negative 4 on the bottom.
Ah, no. This is always changing y over changing x. Here, if you do it by this method, this is your change in y, because these are your y coordinates, right? This is your change in who? That's why I do this. See this? This one goes down underneath it, right there. So you make the fraction by doing that. Okay? All right.
Oh, that's what you do.
How we doing? Yeah? Any questions off of these before we move on? This is your last chance, guys. This is what you made not so good on, right?
Wait, so how do you get negative? Oh, because of the 4?
Yeah, 0 minus 4.
Wait, you do it straight across?
No! Whoa, 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 whoa! Whoa, ladies and gentlemen, look. Look. Boom. Boom. 5 minus 0 is 5. 0 minus 4 is negative 4.
No, you had to do it like that.
Yes.
I thought you had to do it.
That's what I've been saying, right?
No, I did that already. I did that.
Okay. Shh. Which problem? Alright, so let me do this. Alright, so let's look at it. -5 minus -3.
I didn't see that.
Son, when you subtract, what?
On this one, you put the 5.
Oh, does it matter which order pair goes on top? No, it does not matter which order pair goes on top, because you're still lining up your X's and your what? Y's. Please turn around, face front.
But I thought you couldn't do community property with subtraction.
We're not doing commutative property with subtraction. So you bring up a good question, but let me show you something. Watch my hands. Does it matter if I start here and look at how much I'm going up and over to here? How's that going to differ from starting here, going back down here? It's going to be the same. So I'm not doing a commutative property on it, am I? You're still looking at it individually. How much am I moving in my Y's and how much am I moving in my what? X's. I blew his mind, didn't I? But that's a good question. Yeah, but see, if you didn't ask that question, listen to me. If you didn't ask that question, you'd have been confused. You're getting your unknowns what? Thank you. Right? Yeah? I got you till the bell rings. Okay? You need to be looking up at me and not down, propping. Now, listen, guys. Can you work a calculator? Listen. Look at me. You are more than welcome to do it, but you need to show work. This is work. But you need to turn around and you need to check it with a calculator. You need to build your confidence in your skills. And you also need to know where you need more work. Does that make sense? Okay? That don't sit there and go on what you got. Now, I need you, listen, tables. I need you to think about this. Tables, we've already done this. If you will compare your change in X and your change in what? Go. Do your tables. Do the next problem. Go. You ready? Now, I'll bring it. I'll get it. Okay? Now, look. I need you to look at this. Hold up. There's two ways I've done this, so you need to stop, drop, look, and listen. The first way, I looked at changing X and changing Y. So from -2 to 4 is 6. It's going up. It's a positive. From 4 to 16 is 12. It's going up. It's a positive. From 16 to 40 is 24. It's going up, so therefore it's positive. Now let's look at changing Y. 50 down to 40 is a change of -10. 40 to 20 is a change in -20. 20 to -20 is a change in -40. It's going down the number line, so it's a negative change. Now, what I've done was I took each one of these rates of change, put them over one another, and simplified them. Every one of them came out to be -5 over 3. See, they're different fractions, but they are equivalent fractions. You know, y'all asked that question, well, what happens if you choose a point way down here? What happens if you choose a point right here? It's the same thing. It's an equivalent fraction, right? But when you simplify it, guess what happens? Guess what happens? You come out with the same thing. Now, listen up. A table is nothing more than a list of ordered pairs. So if you look down here, look what I done. Look at the very bottom. I took, watch me, I took the first two ordered pairs, negative 2 and 50, 4 and 40. I stacked them so my X's would be lined up and my Y's would be lined up. And then I done what I just did on the previous 4 problems, right? Where you subtract the ordered pairs. And guess what I got? The same what? Thing. How about that? I don't care. I don't care, but what I have to see is your work. I got to see work, folks. Got to see work. Okay? That's right. Got to work, work, work. Now, hey guys, look at number 14. Look at me. Note that your X's are doing what? What are your X's doing? They're not changing. So if my X's are not changing, so I've got zeros for my X, right? Now, my Y's can change all day. It doesn't really matter. Because what you have here is 6 over... Now, I chose 6 because that was the first one, right? Negative 1 to positive 5. Negative 1 to positive 5 is 6 spots, right? It's up the number line, so it's positive. So that's where I got 6 over what? 0. Now, that's part over who? Can you have 6 parts of nothing? No. So that's why it's what? Undefined. Now, listen to me, young folks. Do you see underneath this green line? That is 0 change in Y, but 6 in the who? In the X, right? That's not what this table's showing. So it's imperative that you pay attention to who your X and your Y's are because it matters. When you have no parts of 6, that means that 0 divided by 6 is what? 0. Check it on the calculator. One of them will give you an error, and one of them will give you 0. Fair enough? All right. Now, let's look at the last problem. The last problem has to deal with circus peanuts, right? Tell me how much circus peanuts cost. $10 for how much? I need you to take 15 seconds and find me the rate of change. Go. Now, y'all ready? Let's do this thing. Booyah! Woo! Now, I got 10 over what? 2. Because that's cost per what? $10? Yeah, $10 for how many pounds? No, 2. That simplifies down to 5 over what? This 5 over 1 is called a big word called unit rate. Because why? No. It's how much it is per each one, right? It's a unit rate. How much per each unit, right? So $5 for each pound, right? So I want you to think about this. 1 pound is how much? If I pay $15, how many pounds do I have?
3.
So that would be 15 divided by who? My slope. I want you to think about that. 15 divided, I got an output divided by my slope, right? It's 3 pounds. If I got 5 pounds, it's $5 per pound, so 5 times 5 is what? 25. Go. Yeah. If you want him to find the ones up top, you multiply. If you want to find the ones on the bottoms, you will divide. Because look, no, that's wrong. No. I think she told you right, but think about this. If I want to find what this one is, then I multiply 5 times what? 5 to get 25. Oh, yeah, if it's a thing, so 15 divided by 5 is 3, yeah. Okay. Yeah.
Buy 25 pounds of circus peanuts and pay $125 for it.
Yeah. Do you know what constitutes circus peanuts? Those are the peanuts that the elephant didn't want. Hey, look right here. Need you to check this. These are the tables, right? Yes? Look at this work over here. Look at my work that somebody scribbled over. That's work. But look at my rate of change right here. This is 4. Please don't. I'm still teaching. This is 4. 4 over 1. My Y's are changing by 4. My X's are changing by what? So that validates my slope. My slope. Yeah, in this case, it would be a unit rate. You're exactly correct.